Okay, I hope I'm audible to all my students who are attending this particular lecture for the Statistics for Business Economics Part 1 course. In this particular lecture, I'm going to continue with the discussion of the 2024 question paper, which has come up at Delhi University for the Statistics for Business Economics Part 1 course. And this lecture is particularly recommended for all those students who are pursuing Bachelor's in Business Economics, BBE honors from University of Delhi. Now, all my students can recall that in the previous lectures, starting from question number 1, I had solved part A in the previous lecture for question number 1. And if I scroll down the question paper, we had also solved part B of this particular question. Now, in this particular lecture, I'm going to start from the discussion of question 1 part C. So first of all, I hope all students can see question 1 part C on your screens. Let's quickly start from the discussion of this particular problem in this particular lecture. So let's start with the discussion of this lecture. So let's read part C. Question 1 part C. A sample of 19 offshore oil workers took part in a simulated escape exercise, resulting in the accompanying data on time measured in seconds to complete the escape. So we are given the simulated escape exercise time in seconds, and this is the data. Students can see that it denotes series of individual observations. If you look at the data set, it denotes series of individual observations. Remember from our statistical course, statistics for business economics course, we have three kinds of data sets. One is a series of individual observations, then we have discrete series, and then we have continuous series. So this particular question, if you look at the data, it denotes series of individual observations. Now, first of all, we need to construct a box plot and comment on its features. Okay, so to make the box plot, we need the quartiles. We need to calculate Q1, Q2, and Q3. Okay, so let me quickly come to the whiteboard and let's solve this question. So I am just writing the main heading for completeness. We are looking at Delhi University exam 2024. Name of the course is Statistics for Business Economics. Statistics for Business Economics, Part 1. And this lecture is recommended for students pursuing BBE honors from University of Delhi. Okay, so we are looking at the question number 1, part C. I am first of all writing the data given to us. So we are given the following data. We are given the simulated escape time in seconds for a sample of 19 offshore oil workers. 19 offshore oil workers. This is 5, 10, then we have 55, then we have 60, then we have 70, then we have 75, 85, 85, 90, 90, 92, 94, 94, 95, then we have 98, then we have 100, then we have 115, then we have 125, and then we have 190. Okay, so to calculate, to construct a box plot, we first find the quartile. So what is Q1? Q1, which is my lower quartile, is that value such that 25% of the observations lie below this. So Q1 is the size of n plus 1 by 4th item, which is going to be size of, how much is n? N is 19, okay? We are given that there are 90 offshore oil workers. So my sample size is 19. So this is 19 plus 1 by 4th item, which is the size of 20 by 4th item, which is, I can write size of the 5th item. What is the 5th item in ascending order? You see the data is already in ascending order. So the 5th item is 1, 2, 3, 4, 5. That means my Q1 comes out as 70. The value of the upper quartile is coming out as 70. Okay, so that is my Q1. Similarly, let's calculate Q2. So Q2, which we also call as the median, is that value says that 50% of the observations lie below it. Size of n plus 1 by 2th item, which is going to be size of n we know is 19, 19 plus 1 by 2th item. 19 plus 1 is 20, 20 by 2 is 10. So I can write size of the 10th item. And how much is the 10th item? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means my Q2 is 90. So I'm writing it on the top. I'm saving on some space, erasing the initial portion of. The value of Q1 has come out as 70. The value of Q2 has come out as 90. And now I'm going to calculate Q3, which is my upper quartile. If I erase all this off, I can write that Q3 is the size of 3n plus 1 by 4th item. Let's quickly calculate that. Size of 3 by 4, n is 19 plus 1. This comes out as size of 3 by 4 times 19 plus 1 is 20. So 20th item. This is going to be size of 15th item. Because 4 cancels with 20, making it 5, and 3 times 5 is 15. Now, what is the 15th item? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 98 is the 15th item. So on the top, I can write that my Q3 has come out as 98. Okay, so now we can make a box plot. So it's gonna look like this. If I erase this portion off, okay, so I can draw a line like this, and I can take an appropriate scale because the lowest value here is 5 and the highest is 190. So maybe I can start from, let's say, 10, or I can take multiples of 20. I think that is also fine if I take that. So let's say 20, 40, 60, 80, 100, 120, 140. These are all equidistant gaps. 160, 180, and then we have 200. You could have taken some other scale as well. It's up to you. Okay. So my Q2 value is 90. So that comes here. So 90 is exactly between 80 and 100. So this is my Q2. The value of Q1 is 70. 70 is exactly here between 60 and 80. And the value of Q3 is 98. 98 is very close to 100. Not exactly 100, but very close to 100. Okay, so I can make a box plot like this. And then I can stretch the arms of it. So this is how the box plot looks like for this particular data. Okay, so hoping students have understood this. This is how the box plot looks like. All we had to do was find Q1, Q2, and Q3 and then make a box plot of the same. Okay, so if you look at uh, uh, the data mostly falls to the, I'll say, uh, because 90 is the median, you will see that a lot of values are to the left of 90 as compared to the right of 90. So I can say that the data appears to be negatively skewed. Okay, so I can say that the data appears to be, I can stretch the arms here. I mean, I can stretch more arms here because actually, if you look at the data, it has more values to the left of, it has more values to the left of 90. So the data appears to be negatively skewed. The data appears to be negatively skewed. We have more values to the left of 9. Okay, so hoping students have understood this. Now, what's the next part the question is asking us? Coming back to the question also asks us, how large or small does an observation have to be to qualify as an outlier? Remember, outliers are extreme observations in the data set. Are there any outliers in the sample and any extreme outliers? Now, how do we calculate the outliers? First of all, we calculate something called the interquartile range. We calculate interquartile range, IQR. We know that the interquartile range is Q3 minus Q1. So this is 98 minus 70, which comes out as 28. This is my interquartile range. And now I can now calculate what is an outlier. So students should know, first of all, the formula for an outlier. So I can erase this particular part off. I hope students have now drawn the box plot, so I'm erasing this. Okay, so the outlier is given by, outliers are those values that fall outside the range given by uh, Q1. So the lower boundary is Q1 minus 1.5 times the interquartile range. And the upper boundary is, so this is the lower boundary, this is my upper boundary, Q3 plus 1.5 times interquartile. So if it falls outside this range, it qualifies as an outlier. So let's calculate what is Q1. Q1 is 70 minus 1.5 times interquartile range is 28. Q3 is how much? 98 plus 1.5 times interquartile range is 28. So my range comes out as, how much is 70 minus 1.5 times 28? Let's calculate that. So 1.5 times 28 is coming out as 42, and 70 minus 42 is 28. Okay, I am just verifying this again. 1.5 times 28 is 42, and 70 minus 42 is 28, comma, the range is 28 into 1.5, which comes out as 42 plus 98, which is 140. So any value which lies outside this is an outlier. Okay, so you can clearly see that in this particular case, what are the outliers? Values which are greater than 140 and less than 28. They all qualify as the outliers. Okay, so outliers are the values which are, uh, let me check this again, students. I think there's some mistake being made. 70 minus 1.5 into 28. So Yeah, this comes out as 20 only. So 28, and this is 140. So extreme outlier is obviously, if you look at the extreme outliers, they are the values, I'll say, so in this particular case, 190 is an extreme outlier. Okay, so hoping students have understood this. So anything lying outside this range is an outlier. Okay, so I can write this to be clear that outliers are values outliers are those values that lie outside the range, in this case from 28 to 140. Okay, so hoping students have understood this. And now, if we move forward, let's look at the next part of this question. Coming back to the question paper, let's look at question D. Okay, so question D further has two parts, part 1 and part. So question D, part 1, the Carl Pearson's measure of skewness for a distribution is 0.4. Coefficient of variation is 30%. Mode is given to us as 0.88. We need to find the mean and the median of the distribution. So we are going to use the formula for the Carl Pearson's measure of skewness and the formula for coefficient of variation to find the mean and the median. Okay. So coming to the whiteboard, erasing all this off, question D, question 1, part D, part 1. We are given that the coefficient of variation is coefficient of variation is 30%. 30% I can write as 0.3 also. And we are also given that the Carl Pearson's measure of skewness, SKP, is 0.4. And we are given that the mode is 0.88. So students can recall from my lectures in skewness and kurtosis, which I have covered in my statistics for business economics part 1 course. Okay, so what's the formula for Carl Pearson's measure of skewness? SKP. If students remember the formula, it was simply the mean minus the mode over the standard deviation. And the formula for coefficient of variation is just sigma over standard deviation over the mean. So coefficient of variation is 0.3 given to us equals sigma over the mean. Mean is what I need to calculate. So I can write, let me call for simplicity, let mean be equal to mu. Usually we take the mean as mu. So I can say that 0.3 is equal to sigma over mu. So which implies, what is sigma? 0.3 mu. So my SKP is 0.4. Mean is mu. Mode is 0.88 given to us. Over what is sigma, guys? Sigma is 0.3 mu. Remember from the coefficient of variation formula, sigma is 0.3 mu. Now I can solve this for mu. So 0.4 into 0.3 mu is equal to mu minus 0.88. So I get 0.12 mu is equal to mu minus 0.88. So this implies 0.88 is equal to mu plus 0.12 mu, which implies 0.88 is equal to 1.12 mu. So what is my mu? 0.88 over 1.12. If I calculate this, how much is the mean I get? 0.88 divided over 1.12. Okay, so It's coming out in decimals. Let me verify if we are correct. We haven't made a mistake anywhere. Let me just check this again. So till here, this is correct. 0.4 into 0.3 mu is 0.12 mu is equal to mu minus. Okay, I think in the question it was 88. The mode was 88. Okay, please make this correction. I think there's something wrong in the paper. Let me correct this. The mode is 88, guys. It's not 0.88. Please correct this. All the students can correct this. In the question paper itself, there's a printing mistake. Actually, mode is 88, not 0.88. So I request all students who are watching this lecture to please make this correction. I'm repeating it again. It's a printing mistake in the question paper. I have verified it myself. Mode is 88. That means here, instead of 0.88, we have 88. Please make this correction. So now we can solve. This is mode is 88. So mu minus 88. This is mu minus 88. So now I can write that 88 is equal to mu minus 0.12 mu. So 88 is equal to 0.88 mu. So my mu comes out as 88 over 0.88, which is 100. Now we are correct. I'm repeating it again. The mode in the question, there was a printing mistake in the question paper. Instead of 0.88, it's 88. Please correct it. So we use the formula for coefficient of variation, which was 0.3. 0.3 equals sigma over mean is mu. So sigma is 0.3 mu. The formula for Karl Pearson's measure of skewness is with mode. Mean and mode is mean minus mode over standard deviation. SKP is 0.4. Mean is mu. Mode is 88. And sigma is 0.3 mu. I solve for mu, I get mu as 100. And once I've got the mode and once I've got the mean, finding the median is quite easy now. So if I erase all this off, so I can write mode is equal to 3 median minus 2 mean. 3 median minus 2 mean. So mode is 88. Median I need to find out. And how much is my mean? Mean has come out as 100. We have calculated mean, which is mu as 100. So 88 is equal to 3 median minus 200. So I can write 3 median is equal to 200 goes to the left hand side, becomes 288 with 88. So median comes out as 288 over 3. Median is 288 over 3. And if I do 288 over 3, that comes out as 96. So my median is 96. So this is what we had to find out. These are my answers. The mean is 100, median is 96. Okay. Now coming back to the next part, part 2. If square root of beta 1 is 1, beta 2 is 4, these are Karl Pearson's measures of skewness cutoffs. The students can recall. Variance is 9. Find the values of the third and the fourth central moment and comment upon the nature of the distribution. So this is again quite easy. Question D, question 1D, part 2. We are given that square root of B1 is 1, beta 2, square root of beta 1 is 1, beta 2 is 4, and variance is 9. Now, recall from my lectures on skewness and kurtosis. Recall from my lectures on descriptive statistics only, where I've covered skewness and kurtosis as well. Students can refer to my lectures on descriptive statistics, particularly on skewness and kurtosis. The formula for beta 1 is actually mu3 square over mu2 cube, where mu3 is the third central moment and mu2 is the second central moment. Mu3 is the third central moment. When I say central moment, it's the moment about the mean. Third central moment, and mu2 is the second central moment. I'm repeating it again. Central moments are all moments about the mean. Recall. Central moments are moments about the mean. Central moments are moments about the mean. Okay, so I can take square root on both sides. So I can say square root of beta 1 is equal to square root of mu3 square over mu2 cube. Square root of beta 1 is how much? 1. So this is equal to mu3 square. If I take the square root of mu3 square, it becomes mu3. And if I take the square root of mu2 cube, it becomes mu2 to the power 3 by 2. If I take the square root of. So what do we get? So I get this implies mu3 is simply mu2 to the power 3 by 2. And variance is nothing but the second central moment about the mean. So recall point number 1, central moments are moments about the mean. The second central moment is the second point to recall. Second central moment about the mean. The second central moment about the mean is exactly equal to the variance. That means we were given in the question. In the question, we were given that variance is 9. So mu2 is 9. So this implies mu3 will be what? Mu2 is 9. So 9 to the power 3 by 2, which will be 9 to the power half cubed up. Remember 3 by 2 I can write as half to the power 3. So 9 to the power half is 3 and 3 cube is 27. Okay, so what do we need to find out? I'm repeating it again. If you come back to the question, we need to find the values of the third central moment and the fourth central moment. I need to find mu3 and mu4. Mu3 I've already found out. So answer mu3 is 27. Now, how do I find mu4? To find mu4, I make use of beta 2, which captures the kurtosis. So if I erase all this off, remember from my lectures, what was the formula for mu4? What was the formula for beta 4? Let me correct myself. Beta 4 is simply mu4 over mu2 square. Now, beta 4 is how much? 4. Mu4 I need to find out. Mu2 is 9, right? So 9 square. So this implies how much will mu4 be? 4 into 9 square, which is 4 into 81. So my mu4 comes out as 320. So I'm writing it here. The fourth central moment about the mean is 324. This is what we had to find. And now how can we comment on skewness and kurtosis? You can see that clearly since beta 1, remember guys, square root of beta 1 is 1. So what is beta 1 if I square both sides? Beta 1 is 1 square, which is 1. So since beta 1 is more than 0, it implies that the distribution is positively skewed. Again, for this, watch my lectures on skewness and kurtosis within the descriptive statistics module. Distribution is positively skewed because beta 1 is positive and beta 2 is more than 3. Look at the value of beta 2. What's the value of beta 2? 4. It's more than 3, which implies that the distribution is leptokurtic. I have clearly mentioned this in my lectures on skewness and kurtosis. If the value of beta 2 is more than 3, leptokurtic, which means highly peaked. If the value of beta 2 is exactly equal to 3, mesokurtic, moderately peaked. If the value of beta 2 is less than 3, it is platykurtic, low peaked. In this case, because beta 2 is strictly more than 3, the distribution is leptokurtic. Leptokurtic means it is highly peaked. The distribution is highly peaked. Okay, so with this, we are done with question D, part 2 as well. I stop in this particular lecture. We are finally done with question number 1. It had parts A, B, C, and D, and we have solved all of them. In the next lecture, I'm going to start from the discussion of question number 2. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.